I'm going to work through a little review here on long division. It's a topic that some people kind of forget as they go through school. So I'm going to assume that you have some sort of experience. Maybe you learned it, way back in elementary school or middle school, and you can't seem to really remember how long division works. So this will just be a quick review helping you through the long division algorithm. This won't be any crazy, Common Core kind of stuff that they might teach for long division. This is just probably how, you might have learned it or your parents might have learned it going through long division. So the way we start is we want to see the number on the outside is the number we're dividing into our number. So if we see something, another way to write this expression right here would be 1780 divided by 5. Or we could also write it as the fraction 1780 over 5. That would be another way to write the exact same thing. And now that we've got that, we can see, okay, we're going to see how many times 5 can go into 1780, or how many piles of 5 could I make out of 1780 things, or 1,780 things. So what I'm going to do is start by looking at how many times 5 goes into that first number there, 1. And we can see that 5 doesn't go into 1 because 5 is bigger than 1. So we're going to check one number over, and we can see that 5 does go into 17. So what I usually do is I usually underline that first part. So 5 goes into 17, and since 7 is the first number that we came up to when we used it, that's where I'm going to start to write my answer. So up top here, the answer is going to pop up as I divide through. So 5 goes into 17, let's see here, so that would be 3 times evenly, because 3 times 5 is 15. And then what we're going to do is multiply the 5 times the 3, we're going to get 15. And then we will take the difference of these two numbers. So how much was left over? So 5 times 3 was 15, but then that didn't go in exactly evenly, so there's still 2 left over. Okay? So now what we're going to do, we're not done yet, we just divided into the 17 part. Now we bring down the next number, which is an 8. And now I'm going to be working above the 8 here next. So let's see here. 5 goes into 28. Well, that should be, I think, 5 times. Okay, so we know that 5 times 5 is 25. If we want one more 6, that's 30. That's too big. So 5 times 5 is 25. And then what I'm going to do here is subtract. So 8 minus 5 would be 3. 2 minus 2, that's 0. And then now I've got one more number here to bring down. So we'll bring this guy all the way down here, and we'll pop that 0 at the end. Now, we did say before that 5 goes into 30 and even 6 times. That's nice. And then when we multiply here, 5 times 6 is 30. And we subtract, we get 0. So now we've actually just found that 5 goes into 1,780 356 times. So that would be our answer here up top. And we can always check our answer by multiplying 356 times 5 to see if this works out, if that gives us 1,780. And I'll work through this one just to show you here. So 5 times 6 is 0, carry the 3. 5 times 6 is 30, carry the 3. 5 times 5 is 25. If we add that 3 here, we're going to get 28. We'll carry that 2. And then 5 times 3 is 15, carry the 2 is 17. So we can see that that does give us the same answer here. If we did not get a 0 here at the end, that would tell us it doesn't go in evenly. And if your math problem wanted you to write remainders, you could say, it had a remainder of whatever it came out to be. Or you can keep dividing with decimals, which I'll show you here in the next one. So let's try this next one out. I'll work through this one a little bit quicker here. So we'll start off. 4 goes into, again, we're going to start with that first number there, which is 8. So 4 goes into 8. That's nice evenly, so that does go in. We don't have to jump to the next number. 4 goes into 8 2 times. 4 times 2 is 8. That's nice. And when we subtract, we get a 0. Now, we're not done like we were on this one. That just means it goes in evenly here at the beginning. We still need to bring down this next number. Okay, so now 4 goes into 0, 2. That's just 2. Well, 4 is bigger than 2. So 4 goes into 2 0 times. So we need to sneak a 0 up here now if it doesn't go in. So 4 times 0 is 0. And if we subtract, 2 minus 0 is still 2. And we're going to bring down the 5. 4 goes into 25. That should be, I think, 6 times here, because 4 times 6 is 24. And if we subtract here, 25 minus 24 gives us 1. Now, at this point, if your teacher wanted you to write a remainder, you could write this as that it goes in 206 times evenly, and then there's 1 left over. In fact, if you multiplied 4 times 206 and then added that 1 left over, you should get 825. Now, what we're going to do is actually keep dividing here. We're going to go with decimals in case your teacher requires that. So what I'm going to do now, since I ran out of numbers and there's no decimal point, we know the decimal point goes at the end of our number. Okay, so I'm going to sneak a decimal point right here after the 5. And now I'm just going to keep continuing as before. There's an invisible 0 at the end of any decimal number, so let's bring this guy down and we'll sneak a 0 in here. Okay, so 4 goes into 10 2 times. Sneak that in here. So 4 times 2 is 8. And if we subtract, that'll give us a 2. 10 minus 8 is 2. And now, you know what? We still have a remainder, so we've got to bring down another number here. So we're going to bring down a 0. Now, if we look at this one more time, we've got 4 goes into 20. We're going to line it right above that 0 5 times. That's evenly. So we're actually going to be done at this step. 4 times 5 is 20. And when we subtract, if we're out at 0 here and there's no numbers left here, we could keep adding zeros if we want, but that won't really help us. We'll just get 0.250000. But we can see that 4 doesn't go in evenly. It goes in 206 1/4 or 0.25 times. Okay, and again, if you multiplied 4 times 206.25, you should get 825. All right, let's check one more here. So again, if you want to pause the video at any time, or if you want to go back to these examples without me having worked them out and try to work them out on your own and just check the answer, feel free to pause it. But I will start this one here now. So 12 goes into 6. Well, that doesn't go into 6. 12 is bigger than 6, so we need to go one more number over, so that would be 60. And 12 actually goes into 60 an even 5 times. So let's check that. 12 times 5, so where all those times tables were helpful back in the day, so hopefully you're good with those. If not, again, you can always make flashcards to try and get better at them. Usually up to 12 is a good idea. So if we subtract here, we get 0. Now I'm going to bring down, actually it's kind of weird, I've got a 0 to bring down. 12 does not go into 0 at all, so I'm going to sneak a 0 right up top here. If I take 12 times 0, again, that gives me 0. We subtract just like before, and we still get 0. And now I'm going to bring down the 6. Now you can see again, 12 doesn't go into 6 either, so I'm actually, again, going to have to sneak a 0 here above the 6. It goes in 0 times. 12 times 0 is still 0, and if we subtract, we're going to get 6. Now, again, you could write this if you wanted to as a remainder of 6. You would have 500 remainder 6, or if we wanted to, we can add a decimal point here at the end since there's no decimal at all in the problem. And I'm just going to add a 0 here at the end and see what happens. So I'm going to bring down that invisible 0 that's hiding there. Now 12 goes into 60. Oh, that goes in again. We said an even 5 times, and that's nice because now we're going to be done. 12 times 5 is 60. And if we subtract the 60s here, we are at 0. So we know that 12 goes into 6,006 500 and a half or 500.5 times, and that would be our answer. So again, I'm going to actually probably make another video here on long division with decimals, meaning you have decimals either on the inside or the outside of the division bar, and then show you guys how to work through that. So if you want to stay tuned and find that video, you can. Otherwise, I hope this was helpful.